So if they give us common denominators, I guess they're asking for the lowest common denominator, right? So something like 15, 18, what else? 11? Something like that, right? So if we can find the prime factorization of these, then we'll just multiply everything else by whatever it's missing. So, for example, 15 would break up into 5 and 3. That's its prime factorization. 18, maybe we got 6 and 3. And then 6 would break up into 2 and 3. 11, there's nothing we can do with 11. That's prime already. So, in other words, we have 15, which we'll write down here as a list. 5 times 3. 18 is 2 times 3 times 3. And then 11 is just 11 right there. So 15, if we look at the other numbers, right, we got the 3's that are common, but it also has another 3 that's not common right there, right? So if I multiply this by 3, well, let me make sure that I'm thinking about this right. Yeah, that seems like it should work. Because we have to have common multiples for all these, right?
Right.
So I'm going to multiply it by this 3, but it's also missing a 2. So it needs a 2. But that's just from the 18. If we include the 11, then we also need an 11 there as well.
Okay.
Now it's a big number, which is why it's nice to use calculators, right? Now on the other hand, the 18 is missing a 5, and really we wouldn't need to go through this anymore. I'm just showing this to show that
Basically, you can just times them all together to get
pretty much
a common denominator.
that's correct. Now, again, the lowest common denominator, I mean, maybe we look at these. If the 11 had a 3 that was common there, then we could reduce it by scratching that out right there. Other than that, I mean, yeah, sometimes you get big numbers, but I wish there was maybe a more easier way to do it. There are some calculators that will find it for you, but we can't use them in this class. So sorry about that. I mean, let's look at divisibility by 3. So you guys give me some numbers.
57.
57 more.
16.
16, sorry. We'll make it really big. More.
24.
24. Okay, so let's look at this. This is a pretty big number, 571,624. So let's just see. I mean, right there, we know it's even. So it's at least divisible by 2. But is it divisible by 3? Let's see. So I'm going to separate these. I got a 5, 7, 1, 6, 2, and 4. Now, if I add these, and I get another number that I'm not really sure if it's divisible by 3, then we can add those two numbers as well. So 5 plus 7 is 12, plus 1, 13, 6, 19, plus another 2 is 21, plus 4, that's 25. Now you may know that 25 already is not divisible by 3. But on the other hand, let's say that we tagged on another value for this thing and made it 2 million. Well, now it is divisible by 3 because we can show this as 2 plus 5 plus 7 and so forth. This ends up being 27 right there. So now it is divisible by 3, and if we didn't know that 27 was, we could add 2 and 7 to get 9, and we should know that 9 is divisible by 3. So that's divisibility by 3. Of course, if it's even, we know it's divisible by 2 at least, sometimes 4 or 8.
So it was, you did 2, 3, 5, and was it 10?
2, 3, 5, 10. Yeah, those are the pretty main ones. Those are pretty
When you're trying to break
pretty
it
common
down.
ones, yeah. I'm not aware of a shortcut for 7s or 11s or 13s. Well, yeah, calculator is about the best thing I can tell you. We have that denominator 8, but we don't know the numerator, right? So 16, and these are both already negative, so we're not worried about the negativity of it. So 16, I need this to be an 8 right here. So for 16, I either have to multiply or divide these. I can't add or subtract. So to make a 16 an 8, I would divide it by 2. Now that's how we get the 8, so that's how I should get the numerator there. So I take the 4 and divide it by 2 to get a 2. Now this could be simplified, but that's not really what it's asking for. The 2 is really the answer we want. So number 15 right here, well, there's a couple ways we can do this, and we went over both of them last time, and that was a week ago. So let's look at this way. I'm going to cross simplify these, okay? 28 and 7 can be divided by each other. 28 and 7, 28 divided by 7 is 4, and then 7 divided by 7 is 1. So it's kind of like we're simplifying fractions as though we're 28 over 7. And the only reason we can do this is because it's multiplication. If it were addition or subtraction, even division, we couldn't do that straight across. We had to change it to multiplication. Well, then we got this 36 and 3. 3 divided by 3 is 1. 36 divided by 3 is 12. And then we got this x squared and this x squared, which if we divide them by each other, anything divided by itself is 1. So those just cancel out, which is nice. So what do we got left? In the numerator, I got that 4. 4 times 1 is 4. The x squared went away, same with the 3. And then we got that y cubed. Now you could have reduced that y cubed before, but I want to look at that a little bit differently. Now I've got this 12. And then we got the y cubed. Oh, I'm sorry, y squared on the denominator. The 7 became a 1, and the x squared canceled out. Now we see the 4 and the 12 can be reduced as well. So we can divide the 4 by 4 and the 12 by the same. And that should give us a 1 over 3 now. Well, what about the y's? Well, instead of writing these as exponents, maybe it'd be helpful to see these expanded. Y squared is y times y. Y cubed is y times y times y. And these y's cancel, same with these. And we're just left with this 1y right here. Now if you put 1y over 3, I'm okay with that. Some people get a little picky and they say, I don't want to see the 1 there. And that's okay. Again, for me, that's okay. So this expression, I'm going to change that. I have my dividend, that's the first number there, the a cubed b over c, that's okay. But we don't usually like to divide fractions, we like to multiply them. But if I change this to multiplication, I got to flip or reciprocate this divisor. So that now becomes c squared over ab squared, like this. Now again, with the exponents, it may be helpful for us to see this expanded. So I got a times a times a times b times c all over. And then I got this, I'm going to rearrange these so that I got a, just so they're in alphabetical order, just like the numerator was. All right, now I can see that these a's will cancel. This b's will cancel. Doesn't matter which b you cancel either. And then these c's cancel. So we're left with, in the numerator, we have an a, but we had 2 of those, so a squared. We also had the c there on the end, divided by b. That's all that was left over there. So that is our answer. A squared times c, all divided by b. All right, so 34 here. We got 5 plus 3 over x. Well, that's 5 over 1. So the common denominator that we're going to have to use, as it turns out, will have to be x. So I'm going to have to multiply the 1 by x. In fact, I'll put that on the other side. 1 times x and then the 5 times x. See, now I've got 5x over x minus 3 over x. Well, those are the common denominators. So we'll make it a common denominator of x. And then I'll combine my numerators, 5x, and then minus 3. That's about as far as we can take this one. I covered that with too much ink on that. Yeah, that's plus. I apologize. Yeah. Now, if it was minus, that would be a minus in between there, though. So we'll combine these as well. Now, yeah, this one doesn't have, with that first fraction that we have doesn't have a 1 as the denominator, so it may not be as simple, but you'll find hopefully right here that it is. The 4 and the x. The 4, to make these common, I just need to tag an x onto that thing. But if I do it to the denominator, I got to do it to the numerator as well. And then the x, well, it's missing a 4. And that's all multiplication, by the way. I'm not just saying add 4, subtract 4. This is multiplying. Multiply that by 4, so I'll multiply the 2 by 4 as well. So this is going to come out as negative 3 times x, well, that's 3x, over 4 times x is 4x. And then we're going to add that to 4 times 2 is 8, over 4 times x, which is 4x. Now, of course, we don't really need that, well, I guess we do need that next step. So we have common denominators of 4x, that's what we wanted. But then we got, this is really a negative 3x right here, so I got negative 3x. And then, I got that one right this time, plus 8. And that should do it. So let's look for the perimeter first, then we'll look at the area. So the perimeter, we got the length, and we got the width right here. It doesn't matter which one you say is which. You could say the length is 6 2/3 if you want. But I'm going to set this up. I've got 4 4/5. And this is just for perimeter, so I'm going to add my 6 2/3. Now that's only 2 of the sides. Perimeter is the edges. It's kind of like as if I wanted to box this thing in or fence it in, if it were some kind of property maybe. So I need to add another 4 4/5. And then I also got this side right here, which I would need to add 6 2/3. Now I recommend changing these into improper fractions, but remember we could work with the mixed numbers. So what do you guys want me to do? Improper fractions. All right. So I've got 4 times 5, which is 20, plus 4, 24/5, plus 6 times 3, plus 2, 18 plus 2 is 20, 20/3, plus 4 times 5 is 20, plus 4, 24/5, and then 6 times 3 is 18, plus 2, 20/3. Now, you probably noticed there that we got 24/5 twice and 20/3 twice. That's because, well, we do have different formulas for the perimeter of a rectangle specifically. I'd like to show them all 4 of them, just so I can account for all 4 sides. Because sometimes conceptually we kind of mix up our multiplication. Well, I've got denominators of 3 and 5, so I'm going to use a common denominator so I can combine these of 15. So this first fraction here, 24/5, I'm going to need to multiply these two by 3. So 72 fifteenths right there. And then this one, I'm going to have to multiply these two by 5. So that's plus 100 fifteenths. And then we got 24 and 5. We'll have to multiply these ones by 3 and this one by 5. And they're the same again, so add 72 fifteenths plus another 100 fifteenths. Well, when we combine all these fifteenths, because that's what we have, 72 plus 100, 172 plus another 72, 244 plus another 100, that's a 344 fifteenths. Now I'm okay, personally, and let me check just to make. So I would just leave it like that and say, well, I got 344 fifteenths in feet. Of course, some of us feel uncomfortable leaving these as mixed numbers, and that's okay. We can change this into a mixed number by taking 344 and dividing it by 15. 15 doesn't go into 3, but it will go into 34 twice. Minus 30, that's where a calculator comes in pretty handy. 15 goes into this new 44, still twice. So I'll subtract 30 out of that, and I'm left with 14. So it would have been 22 and 14 fifteenths, It's pretty close to a full whole value. That would have been nice, but no go on this one. So let's look at the area of this thing. The area of rectangle's length times width. And up there we said that the length was 4 4/5. And the width we said was 6 2/3. So we're just multiplying these two. This is where I think it's really nice to have those improper fractions. And since we've already changed both of these, then, well, it shouldn't be too hard. So the 4 4/5 became 24/5. And the 6 2/3 became 20/3. We don't need common denominators to multiply fractions, so we'll just multiply these straight across. 24 times 20 should give us 480. 5 times 3 is 15. I don't think that will. No, it will. That divides into it evenly again. That's where the calculator comes in handy. So 480 divided by 15, and we get 32 on this. So it'd be 32. We should label this, and since the area is two-dimensional, we have to put it square feet. The area of a triangle is different, so we do have to use a different formula for this. The area of a triangle is 1/2 times the base times the height. And on this one, the base is going to be created with this line right here. That's showing us the height or the altitude of that triangle. So this is the base right here, and I'm going to replace the b then in the equation with that 6 5/6. Well, then I need to replace the height as well. And that's just straight across 4 feet, which is pretty nice. That makes it pretty convenient. But we still have that mixed number, 6 6/5, which we should change to an improper fraction. 6 times 6 is 36 plus 5, 41. So that would be 41/6. Then we got the 1/2 times that times 4. You can make it 4/1 if it helps you see that a little bit more clearly. Now I just multiply these straight across. And yes, you could cross simplify right there. We'll do that later. 41 times 4, 164. And 2 times 6 times 1 is 12. And yes, these are at least divisible by 2. So we should simplify this. Divide by 2. So I get 82 out of 6. These are both even. So we should be able to simplify these as well by 2 again, which gives us 41/3. 4 plus 1 is 5, which is not divisible by 3. So it looks like the area is 41/3 in feet squared, or square feet. This one's not too bad. That would be 13 2/3 square feet. But again, I'm okay with the improper fraction there. If elephant grass grows at 2.5 inches a day, how many inches will it grow in 6 days? All right, so every day, for 1 day, we know that it's going to grow 2.5 inches. Well, on day 2, let's just put this as day 2, it'll grow the same, right, at 2.5 inches. So if we keep adding these, it's the same as multiplying these. So you'd have 2 1/2 inches. And we can multiply this by 6 days. Now, if you wanted to add them, that's okay. It's not going to make any difference to me whether your work is adding or multiplying. Now, if we do multiply these, even if we add them, we're still going to need improper fractions. So 2 times 2 is 4 plus 1. That becomes 5/2. And I'm going to multiply this by 6, or 6/1. And if I multiply 6 times 5, I get 30. 1 times 2 is 2, and we can simplify this. 30 divided by 2 is 15. So how many inches will it grow in 6 days? And yes, we do need to label these on the test, okay? 15 inches. 54, it says you only have 1/4 of a cup, right? And you want 7 1/4 cups of flour. That's nice of them to put that as 1/4. And you could count them. Again, you need to show some work on the test, though, okay? You need to see something. Well, even if you draw a picture, I'd be fine with that. But really, it would just be nice to take this 7 1/4, and we'll divide it by fourth cup measuring cups. Well, 7 1/4, that should give us 29/4, and then we'd multiply this by 4/1. See, that's why it's nice for the denominators be the same, because those 4's cancel out, and I'd get 24, I'd just say 24 times. You'd have to pour that cup in 29 times. 29 fourth cups, just be careful, that sometimes looks like a mixed number.